friends, welcome back to our channel Physics Tutorial. Today we are going to continue the semiconductor electronics. In the last video we had discussed semiconductors, then forward biasing, reverse biasing, etc. Hope it was clear to you. Now we are going to continue with the discussion of semiconductor diodes, that is the application of junction diode we are going to study today. So if you have not watched the last video, please watch it before going ahead with this video. Otherwise it will not be able to understand the concept that we are discussing today. Today we have a very important topic, and now we can move to that, rectification. Are you ready? Here we have the application of junction diode, that is diode will act as a rectifier. So that is the first application that you have to study. That is, what is rectification? Rectification, have you heard about rectification? That is, we know that there are two types of electric current, that is direct current is there and then alternating current is there. So in the case of direct current, the magnitude and direction will not be varying with the time. Okay, so that means we can see like this, the direction and magnitude will not be varying with the time. It will be coming like this. Okay, so constant current we will get in the case of DC, that means direct current. And what about AC? That is alternating current, right? That we have already studied, but okay, so this should be straight. Here we can draw again. Okay, so here we have alternating current like this. Here we are taking two cycles. Here this magnitude as well as direction is varying continuously with the time. So this is called alternating current and this is direct current. So that is the difference between this AC and DC. Now what we are doing is, we are doing the rectification. So in the case of rectification, we will convert the AC into DC. Okay, so that process is called rectification. Rectification is the process of converting alternating current into direct current or AC into DC. So that is called rectification. This is very important topic and you should understand the concept clearly. Okay, so here this is the case of rectification. Here we will give the input as an AC and we have to get output as DC. So for that, we will use the feature that we have studied in the last class. That is, when a diode is, that means that semiconductor diode is connected in forward bias, there will be conduction. Okay, that will conduct. Then in the case of reverse biasing, what will happen? There will not be any conduction. Okay, so that is non-conducting. So that principle or that feature we are using in the case of rectifier. Okay, so here we can see the half wave rectifier and full wave rectifier. So first of all, we can start with half wave rectifier. And in the case of half wave rectifier, here we will use a transformer and this is an AC circuit we are using here, and this is a semiconductor diode. Okay, here we will use the RL, that means the output load resistor. This RL means load resistor, and always we will take the output of a circuit from the resistors, that will call as load resistor, and here we will get the output. Okay, so that circuit first of all we have to construct, and the circuit, after getting the circuit we have to know how the input and output varies. Okay, now we have to construct the circuit. So that circuit diagram you have to study. So here we can apply the input voltage as AC. Okay, so here this is the input and here we are applying this through a transformer. Here we have a transformer and we will apply this to a transformer. Here we can see one end of the transformer is connected to the semiconductor diode, and this symbol should be the same because here we are applying this to positive side and this is negative side, and that negative side we are connecting to the load resistor. This is called load resistor, and the other end of the transformer, that means secondary of the transformer, we are connecting to the load resistor. We will get the output, that means DC output here in the load resistor. And here we can see the input. Here we are applying the AC input, that is shown here. Clear? Now this is only the circuit. Here we can consider the end as A and this end B. Okay, now we can look into the working, how the half wave rectifier works. For that, it is very easy to understand the thing. That means when we apply the AC, what will happen here? The end A, suppose the end A is positive here. So the input we are giving like this. Here we have the input. Here, this is one cycle. Okay. And this is the second cycle. Right, two cycles are shown here. This is the first cycle till here, and from here we have a second cycle. And during the first cycle, what happens here? During the first cycle means till here. What happens? This is positive, right? This is positive half cycle, and this is negative half cycle. Again, positive half cycle, negative half cycle, like that. It is coming, right? And when we switch on that here, what will happen? AC is coming here. Suppose the end A is positive. At first, if the end A is positive, what will happen? This end A positive means this positive is connected to the positive of the diode. So forward biasing is here. Okay, so the negative will be connected to end B. Right, so the current flows through the circuit, and here we will get the output as this. This is the output, so that we can draw here. So in this case, what happens? The output will be in the same way. Here we are getting the output. So this output is also very important. So here we are getting the output, and in the second half cycle, what will happen? That is the negative half cycle. This will be coming. So this positive will be, yes, replaced with negative. So that will be becoming as negative. So negative, what will happen here? The negative means the negative of the cell is connected to the positive of the junction diode. That means this is reverse biased. In the case of reverse biasing, what will be the output? Nothing will be there, right? So here there will be no output. So that is shown here. Here we can see no output is here. And in the third case, what will happen? This positive half cycle again will come. That is the second positive cycle, right? So what will happen? Again, this will be positive. Then it will conduct, and the output will be given here. And in the last case, what will happen? Again, it will be going to the negative half cycle. So again, this will become negative. So again, this is reverse biased. That means there is no output here. So what we can understand from this? Here, only one diode we are using. Right. So only one diode we are using means only during positive half cycle of the input we are getting the output here. Okay. So in the other half cycle, what is happening? No output is there. So the output will be like this. This is DC, but it is not complete. Okay, half portion is lost. So half of the input only we are getting the output. For only half of the input we have output. The rest of the input is just eliminated from this side. Okay, so we can't get the output of these two portions. So for getting the complete output, we have to use full wave rectifier. So hope it is clear to you, this half wave rectifier. Here I will just explain that once more. Here we have an AC circuit. Okay, AC input we are giving. This is the input, and here we can see this is the input, and this input we are applying to the transformer, and from the transformer we are connecting to the diode, that is semiconductor diode, and from the negative side of the diode we are connecting to the load resistor, that is the output. Okay, here the end B of the transformer is also connected to the load resistor. This is the circuit. And how does it work? When the positive half cycle of the AC circuit is coming to the positive side of diode, it will be forward biased, then it will conduct. Okay, so we will get the output. And in the case of negative, that means if the negative half cycle is coming here, or what will happen? It will not conduct, because that will be reverse biased. In such a way, we will get the output here. And for getting the complete output, what we can do? We can use this full wave rectifier. So that we can do. How to find the full wave rectification, that we can discuss now. Here we can see a full wave rectifier. So for that we are using this AC input, then a transformer. Here step down or step up transformer we can use, or an ordinary transformer is not possible to use here. We can use that, but we have to take 4 diodes. So with only 4 diodes we can use the ordinary transformer. So instead of ordinary transformer, here we are using a center tap transformer. That is the difference from half wave rectifier. Okay, so if we are using this center tap transformer, we can see here that 3 outputs will be here. So when we were using the ordinary transformer in the last case, but we were getting only 2 outputs we were getting, right? So here we can see that here we have 3 outputs. Okay, so that is the case of a center tap transformer. So for that we are using this center tap transformer and 2 diodes, similar diodes we are using, and the output will be taken along this load resistor. So these are the connections here. Here we can see the AC circuit we are applying, that means AC input we are giving here, and it is connected to the transformer. Okay, so from transformer both the diodes we are connecting in a similar way here. Okay, the positive is connected to this end A, and negative we are connecting together here, and from the negative we have the load, that means the RL, load resistor we are using. Here we will get the output. So this is the center of the transformer. Here we are connecting this to load. Okay, so this is the connection of a full wave rectifier, and how it works that we have to see. So here we have 2 inputs, right? Here the inputs we can see here, this is at A and this is at B. These are the inputs, and the output we can see how we will get the output. So how it will work? During the positive half cycle, that means during this half cycle, what happens here, one input is here and the other input is here. Okay, so what will happen here during the positive half cycle, this will be positive, so this end will be positive and this will be forward biased, right? Then we will get this part, only the half of the cycle. Okay, half cycle we will get here as the output. And in the second case, what will happen here, suppose this is negative, and then first of all this was negative, right? Then in the second case, what will happen, this portion is coming, right? So this will be positive and this will be negative. Clear? Here we can see this is the second portion, this is positive and this is negative, right? So this will conduct. Here this is forward biased and this is reverse biased. So what will happen here, this is conducting, this portion is conducting, that means here we will get the output. And in the third case, what will happen, again this will be positive and this will be negative, right? Okay, so what negative is coming here. Okay, then what will happen here, this will be forward biased and this will be reverse bias. So D1 conducts and D2 will not conduct. Like that we will get. So for alternating cases, that what happens, D1, D2, like that it will conduct. So first of all D1 conducts, then D2 will be yes, reverse biased. Then D2 conducts, then D1 will be reverse biased. So the output we can see here, that is here we are getting the complete wave. Okay, but it is in the DC form. But the main thing is that here we are not getting a exact DC. Okay, DC means here it will be that magnitude also should be the same, right? Here we can see a fluctuation here. So we have to remove that fluctuation, and for that we will use filter circuit, so that we can just see in the next case how we can remove this ripples from this output. Okay, so this is a fluctuating DC, not the correct DC, a fluctuating DC we are getting, and that fluctuation we can remove from this by using filter circuit. So here in the case of full wave rectifier, what we have to remember is that we are taking a center tap transformer instead of ordinary transformer, and there are 2 diodes D1 and D2, and here we are applying the input AC input and we are getting the output AC form. The output and input forms you have to remember how to draw this and the circuit diagram also. Now we are moving to the last topic of this chapter, that is capacitor filter. So in the last case we had discussed that from full wave rectifier and half wave rectifier we were getting the output as DC, but even then there was a small fluctuation in the output. It was like this. Here the fluctuations were there like this. Okay, here there was a fluctuation in the output, and that was the due to this AC components present in this. Okay, so AC ripples were there. Due to that, the fluctuation was there in the output DC. So for removing that fluctuations, we can use this capacitor filter. So here the properties of capacitor is made use of in this filtering. Okay, so we can see the symbol diagram here. We have the AC input, that means whatever we are getting from this, so that here we can apply the AC input and the rectifier is given here. So the whole circuit is included in this. Okay, so here suppose we are using a full wave rectifier, we will get the output like this. So here we are applying the AC input and here we are getting the fluctuating DC output. Clear? So this is fluctuating. So here what will happen? Here we are connecting a capacitor only and then to a load. This is a simple circuit for the capacitor filter. So here the only thing that you have to remember is this: the rate of fall of voltage across the capacitor. That means the rate of fall of voltage across the capacitor depends inversely upon the product of capacitance and resistance. Got it? That means here in the case of capacitor, we know that if we are charging that, that will be completely charged. Okay, once it is completely charged, what will happen? That will discharge through the load. Okay, if a load is connected to the end, what will happen? This after getting completely charged, this will start to discharge. So that discharging, that means the rate of fall of voltage, that means the discharging across a capacitor. So that depends inversely upon the product of capacitance and resistance. We can easily say that rate of fall of voltage, that means during the capacitor discharge, what will happen? That discharging will be proportional to 1 by CRL. Only this factor you have to remember here. So 1 by CRL is the quantity that depends upon the fall of voltage, okay, across a capacitor. So here this CRL is called time constant. Time constant means CRL, that is very important. CRL is called time constant. And here what happens? If CRL or time constant is very high, what will happen? The value rate of fall of voltage will be very less. Right. So our aim is to make the CRL very high value. So for that we have to use very high value capacitor for that. So high capacitance we have to use here for getting the time constant as a high value. So if the time constant is high, what will happen? The rate of fall of voltage becomes, yes, very less. What is the meaning of rate of fall of voltage? That means the discharging will be happening very slowly to this. That means the next input might have reached here in the capacitor. So that here no time lag will be coming. This will be just like this ripples. So instead of like this, here we will get a fluctuating. Only small fluctuation will be there for the output. Clear? So in order to get that rate of fall of voltage as very small, we have to use this capacitor, high capacitor value we have to use here. So that is the case of a capacitor filter. So you should understand only this much things, that is capacitor filter is used to remove the AC ripples present in the DC output, and here we are using the AC input and rectifier is kept here, and the output will be DC will be there. Okay, and that DC we are passing through the capacitor and then it is connected to load resistor. This is the load resistor. Output we are taking through this. So when the capacitor is charged, means that will completely charge, and after that it will start to discharge. So during discharging, if the time constant is very high, what will happen? The rate of fall of voltage will be very less. So when the wave is completely, means the wave is coming continuously, right? The input will be coming continuously like this. Okay, so what will happen during discharging? Even if the one wave is discharging through slowly, what will happen then? Before completing that discharging, the next wave might have reached there, so that it will not make this lagging here, and there will be no that much fluctuations. So we can avoid that fluctuations, or we can remove the fluctuation by using the capacitor filter. So hope it is clear to you. Now we can conclude the chapter. Okay, so thanks for watching.